guys, happy Tuesday. How's it going? Hey kiddos, so I've combined groups C and D. If you could please go ahead and self-mute. Please go ahead and click on your microphone and self-mute. With a larger group, it is kind of necessary. Awesome. Good, good. So it sounds like if you guys could please self-mute. Appreciate that. Thank you. So happy Tuesday. Please go ahead and self-mute so we can begin. I'm going to click on over to Nearpod, if you don't mind, just to check in to see how many people are currently on. Wow, looks good. 9 students ready, which is great. So it looks like we have Camilla, Adriana, AJ, Akash, Emily, Isabella, Camilla, Nathan. Looks good. Hey, so once again, if you could please go ahead and click on your microphone, self-mute, and we're going to go ahead and begin. So please remember that Nearpod is basically just a visual way for us to communicate. It will be like a digital whiteboard, and Teams will just be a way for us to communicate. I will probably be flipping back and forth from Teams to Nearpod. If you do have a question, just put your finger on your nose. Obviously, you can't raise your hand because then I won't see your hand, but please put your finger on your nose, and if I see someone putting their fingers on their nose, I'll know they have a question. So you're probably wondering, hey, why are we tackling 4th grade concepts? Well, as you guys know, what better time? 3rd grade, the last 2 months, I want to get you guys ready for 4th grade. You know, if we weren't having this distance learning, we would be reviewing all the concepts I've taught the last 6 months for that end of the year test. But as you guys know, that's gone. So I'm going to get you guys ready for 4th grade. 3rd grade to 4th grade, that transition is super hard. But guess what? Because of all this hard work we're going to put in these next 2 weeks, or sorry, 2 months, you guys, you're going to enter 4th grade knowing most of the hard, challenging math concepts. So let's begin. Now, you guys have heard me talk about knowing your multiplication facts. The reason why most of you guys are in this group is because you're 100% proficient with your multiplication and division facts. If you know your multiplication facts really quick, then you can solve a 3-digit or 4-digit problem. This is what we call a standard algorithm. Your parents, I was taught this way. Most of the country was taught this way 20 years ago. It's not until recently, in the last 5 years, that they've started using different strategies. You guys saw me talk about the area model. An area model is a new Common Core strategy. And I'll be honest, some parents look at that and they're like, I wasn't taught that way. I wasn't either. As your teacher, I had to learn Common Core and basically teach you guys multiple ways to solve the problem. So what I want you guys to do is kind of analyze. This is what we call a standard algorithm. If you take a look at the red number, the 5, and we're going to be making 5 groups of 639. Remember when you were in 2nd grade, they asked you to make, let's say, 5 circles, and then you make dots inside those circles, 5 groups of something? Well, 5 groups of 639. How long would you be there making 639 dots in each circle? A really long time. So that strategy is not going to work. So this is a standard algorithm. We're going to think about 5 times 9, the ones times the ones. And as you guys know, 5 times 9 is 45. Next, we're going to think about the 5, the ones times the tens. So that red number times the green. That's 1 5 times 3 tens. So 3 times 5, or 5 times 3 is 15. But as you guys know, that's not 3 ones, that's 3 tens. So 5 times 30 is 150. And then if you look at the red number and you multiply it times the blue number, once again, 5 times 6, it's not really a 6, it's 600. And 5 times 6 is 30. You add those 2 zeros, it's 3,000. So we'll talk about this. Obviously, really, the only 3 multiplication facts you guys need to know is 5 times 9, 5 times 3, 5 times 6. Everyone knows those multiplication facts. And then you just add the necessary number of zeros. So if I'm going to switch back over to Teams, would you give me a thumbs up if you you're understanding this, or like, Dufour, what language are you talking? It's all right. That was the first, it was the first example. It's totally fine. We're going to move forward. You're going to get some practice and I'll be able to guide you. So here's another problem. And take a look at this 4-digit number. This is 1,345. So if we analyze that number, it's 1,000, 3 100s, 4 10s, and then 5 1s. And basically what we're doing is we're multiplying it by 3. And if you look at the small little rectangular box, it's showing you 3 times 5, so it's the 1s times the 1s, 3 times the 40, which is the 1s times the 10s, 3 times 300, which once again, it's 3 times 300, and then 3 times 1,000. And you're probably looking at these 5 numbers, the 15, the 120, the 900, the 3,000. These are called partial products. Another word, partial add-ins. What we're doing is we're combining all those numbers, and the product is your answer. The product is the total, okay? So please spend just a second and analyze this. Now, this is how we were taught. This is called the standard algorithm. And I'll be honest, there are some students who figure out, okay, the sequence, 1s times 1, 1 times 10, 1 times 100, 1 times 1,000, but truly number sense wise, they may not really understand what they're doing. And that's why Common Core figured out, or they started trying to roll out new strategies to help kids with their number sense. Because if they just memorize a pattern and truly don't understand why they're multiplying and what this visually represents, then it really is pointless, okay? But I want to show you a few different strategies to help you with 3-digit and 4-digit multiplication. All right, so once again, 74 is a 2-digit number. All you really need to know are the multiplication facts, 4 times 8, and really 8 times 7, and then you add a 0. So can you please go ahead and set up your problem? 74 times 8. And I know some of you guys have been practicing this over the last few days. What I'd like to do is ask for you to use the Nearpod app, use your drawing tool, and please go ahead and write out 74 times 8. I want to walk you through this. This is, yeah, great job, Camilla. This is a regrouping problem. As you guys know, when you're multiplying the 8 times the 4, there we go, you're going to have basically 32 ones. So you're going to keep the 2 in the ones place, and you're going to regroup those 3 10s. You can't put 2 numbers in one digit. Frankly, the 32 ones, the 3 10s now go above the 7. And that 3 is basically 3 10s. So if you have the number 2 in the ones place, you're in good shape. Isabella, what I would recommend doing is setting up your problem vertically, which means up and down. Put your 8, please erase that, and then put it below the 4. It'll help you to think about 1s times 1, which is 8 times 4, regroup the 3 10s above the 7, and then 8 times 7 is 56, and then add that to 56 plus 3, and that will be your product. Akash, way to go, man. Looking great. Just analyzing. Nathan hammered that out. Great job, Nathan. Adriana's slowly working. Almost there. Nice. Great job, Emily M. Jaden, way to go. Setting up that problem. So think about that. 8 times 4. And so this is why we need to know our multiplication facts. 8 times 4 is 32. We put our 2 1s underneath as the product. Carry the 3 10s above the 7. And then now it's basically 8 times 7, which is 56. Plus the 3, and that's 59 10s. So your answer is 592. I'm liking what I'm seeing, guys. This is awesome. Now, I'll be honest, if students don't have their multiplication facts memorized, things get really tough. As you know, if they're unable to recall these facts really quickly, then a problem like this causes a lot of problems. And being a middle school math teacher, it really saddened me to see tons of 6th graders, 7th graders, 8th graders that didn't know their multiplication facts. Think about all the problems that, frankly, they were unable to do because they hadn't mastered something so simple, something that we work on so long in 2nd and 3rd grade. Kiddos, I like what I'm seeing. Great work. So once again, I would recommend setting up your problem vertically, which means up and down. So 85, and then put multiplication symbol, which is an X right now, and then put the 6 underneath the 5. So the two multiplication facts you really need to know are just 6 times 5 and then 6 times 8. And then ultimately you're going to carry that 0, and 6 times 8 is 48, but it's 480 because it's basically 8 tens, which is 80. Nice. You guys are flying. I already see students setting up the problem. Remember, Andrew, it may be, oh, I like what you're doing, Andrew. I wish I could show this to everyone, and hopefully we'll be able to share this in the near future. This is a great strategy. So what AJ is doing is he's multiplying the 80 times the 6. And if you know 8 times 6 is 48, then it's 480. And then he's just doing the 1s times the 1s, which is 5 times 6, 30. And then he's combining the 480 and the 30. Nice strategy, man. That's great. And see, AJ, this is exactly why Common Core was implemented, because so many kids have different ways of solving these problems. I actually went to college with my wife, and we took a couple algebra classes, and I would teach her my way, and she would get so frustrated because I did things differently and she did things differently. And so it wasn't until the last 5 years that our curriculum has kind of adopted a philosophy of let kids figure out the way that they want to solve and attack these problems. Because when I was a kid, if I did anything different, I solved the problem differently than my teacher, they would not be happy. I love the confidence, Adriana. Easy. I love it. Your 4th grade teacher is going to be stoked when you guys tackle this. Good. So I'm going to jump back to Teams. I want to go ahead and, oh, look at that. I just jumped onto Teams, and Adriana, you beat me to it. She's already throwing that thumbs up. There we go. Hey, Wyatt, thank you for putting your hand on your nose. Do you have a question? Sorry about that. If you could ask your mom or dad or a different device, jump on a different device, see if you can access that. I do apologize. The join code is ZADFL. Please refresh your computer. As you guys know, when we were doing the Nearpod lessons in class, there was always that one student, for whatever reason, things just weren't working. I'm sorry, bud. That's I understand, bud. So I would say then please try utilizing a different device. I wish I had a better answer than that. But if you just go to nearpod.com and then type in ZADFL, you can access from an iOS device, a tablet, anything that has a browser. So I'm going to move forward. So guys, you've seen me do an area model. And once again, I think the area model, now that you guys have learned a standard algorithm, an area model isn't much different than what like AJ was doing. When he looks at this problem, 74 times 8, he thinks to himself, okay, 7 times 8 is 500, or sorry, 7 times 8 is 56, so 70 times 8 is 560. So 560 is in that purple, that purple small portion of the rectangle. And then all you need to do is combine the 8 times the 4, which is 32, and then bring those two numbers together. Now, you may want to go ahead and grab a pencil. If you do have some paper, unfortunately, I didn't have the opportunity to set up a couple drawing screens on Nearpod for these problems, but I would write a few of these down and take a look. If the area model is confusing, don't worry about it. But really what the area model is doing is just showing you the value of a 3-digit number or a 4-digit number. It's breaking it up into place value. So if you look at the second example, 5,607, really the 3 values are 7 ones, 6 100s, and then 5 1000s. And that's 5,607. And you're multiplying that by 2. And if you were to break that down, set that up like a standard algorithm, you would see that it's 2 times 7, 2 times the 600, 2 times the 5,000, and you have your product. Okay? You guys, you may want to write down a few of these